So question 6.1 says 12,000 Rand is invested in a fund that paid interest of M% per annum compounded quarterly. After 24 months, the value of the investment was 13,459 Rand. And we have to determine the value of M. Okay, so money was invested. It grew at a specific interest, compounded quarterly. And then after this amount of months, the value of the investment is this. This is a simple case of compound interest growth. So we're going to use the compound growth formula. Okay, so something that I like to do is I write down the variables that I'm going to have in that compound interest formula. So that is the P value, the A value, I, and N. So you can just remember that acronym PAIN. So I'm going to find the P value. What is P? P stands for your investment. So P, in this case, 12,000 Rand was invested. So we know what P is, 12,000 Rand. And then A, what is A? The A value is the accumulated amount. So the amount that you have at the end of that period. They told us after 24 months, the value of the investment was this. The value is now this amount. So that's our A value. So A is 13,459. Then the interest. The interest, they told us that the interest is M% per annum. Compounded quarterly though. So whatever M is, for example, let's say it was like 14% per annum, right? You would naturally say, oh, okay, that's 0.14 as a decimal. Then because it's compounded quarterly, you would remember to divide by 4 so that it's going to be in quarters. So I'll say over 4. So that it's shared into 4 parts and it ends up gaining interest every quarter. So I'm going to do the same thing for M. So treating M, because they said percent, I'll treat it like it is a decimal. Okay, you can say 0.M if you want, but it's not really necessary. We can just say M and then divide it by 4. And then we'll sort that out at the end and just make sure that we tell them the answer as a percentage. Okay, because they do say M%. Now we have to figure out N. So N is the time period. Okay, they tell us that it is after 24 months. But we also have to remember that this is compounded quarterly. So how many quarters is 24 months? One way we can convert this is normally they usually give you this information as years, right? They would tell you, let's say this thing has been invested for 7 years. So if you knew that was 7, you would have just said, oh, N is equal to 7 times 4 to put it in quarters, right? Instead, they didn't give you this number in years. They gave it to you in months. So how about you just convert 24 months into years, then convert it into quarters. 24 months into years, because 12 months is equal to 1 year, right? To convert 24 months into years, you would just divide that by 12. So this is going to be equal to 2. 24 months make up 2 years. So I'm going to say 2, and then I need to turn these years into quarters. So to turn into quarters, I'll just multiply by 4 because quarters is in 4s. And there we go. So this is going to be 8. And now everything is set. We can just use the formula. It is the compound growth formula. So that is A is equal to P multiplied by 1 plus I raised to the power of N. And so A is 13,459, which is equal to 12,000. And then 1 plus the interest is M over 4 raised to the power of 8. And we just have to try and solve for M. Okay, so to get to M, what do we do? Okay, so first of all, the first problem I see here is there's 12,000. We have to get rid of it. If we divide both hand sides by 12,000, we will get rid of that 12,000 over there. So that's now gone. And then let's see what this is going to give us. Okay, so what I noticed is that it gives me a fraction. It does not simplify. And the decimal is quite long. I would rather not use decimals because when you use decimals, if you round off, it's going to change your answer. So I'm going to leave it like this. I'm not going to change that. I'll leave that as a fraction. And so what I just have here is I have the 13,459 over 12,000. And then this is equal to, we have now 1 plus M over 4 to the power of 8. Now, we're still trying to get to M. the next problem that we have here is this 8. It's blocking us from getting into the m. So we can go ahead and root both sides, but find the 8th root of both sides. So the 8th root and the 8th root. And from the way this looks, I'm not even going to find the answer of this. I'm just going to keep leaving it like this. Now the 8th root is going to cancel and it's gone. And we have now, again, I'm just going to rewrite the 8th root of this number, not changing it because I don't want decimals. And then this is equal to 1 plus m over 4. Now to get to the m, what's stopping you from getting to the m? It is now the 1. So just take the 1 over. So that's this same thing again. And when 1 comes over, it becomes negative because it becomes the inverse. So I'm just taking 1 over, say minus 1 is equal to m over 4. Okay, now at this point, still trying to solve for m. What is stopping us from solving for m? It's the 4. Now you have to ask yourself, what is the 4 doing to the m? Well, it's dividing by the m. So to get rid of it, you have to do the opposite, which is to multiply by it. Okay, so multiply both sides by 4 to get rid of that divided by 4. Okay, so this is how I'm going to rewrite this so that it can get me the answer. I'm trying to multiply this entire thing by 4. So I will use brackets. Okay, so it's like 4 multiplied by the 8th root of 13,459 over 12,000 minus 1, is equal to m. So now we can find out what m is equal to. So I'm going to put this onto the calculator as 4 bracket, then I'm finding the 8th root. So I'll press shift and this. Okay, so just check on top. You should have a 1 with an open number for root. So I'm putting 8 and then inside we're going to have a fraction. So I'm putting 13,459 over 12,000. Then we're going to come out of that radical, use your buttons on the side. Then we're going to say minus 1 and then close that bracket. Okay, so weird number, but I'm just going to press SD so that it can be as a decimal. Okay, so it is 0.05778. I usually leave 5 decimals and then show that I didn't round off yet. But now remember that m must be a percentage because they said at m% per annum, just like they would say at 12% per annum or 14% per annum. You're going to have to leave that as a percentage. So to get this decimal to be a percentage, you need to multiply it by 100. So I'm going to take all of that answer and I'm going to say multiply it by 100 and let's see what we get. So we get this. So m is equal to, as a percentage, m is 5.78 because it rounds up, 78%. There we go. And that's our answer. Okay, moving on to the next question. Then we move on to 6.2, and 6.2 says, on the 31st January 2022, Tino deposits 1,000 Rand into an account that paid interest of 7.5% per annum compounded monthly. He continued depositing 1,000 Rand, so continued depositing, meaning money keeps going in and it's constant, the same amount, meaning this is future value. Okay, so he continued depositing 1,000 Rand on the last day of every month. Last day of every month, this is a consistent, he's being consistent in his deposits. Okay, then he will make the last deposit on the 31st of December 2022. So from 31st January to 31st December, that's just 1 year. Okay, will Tino have sufficient funds in the account on the 1st of January 2023? So he stops here, that's the last deposit, then the 1st of January. If you look at those two dates, you see that that is just 1 day away. So it's not going to earn extra interest. Okay, so on the 1st of January, to buy a computer that costs 13,000 Rand, justify your answer by means of an appropriate calculation. Okay, so as we can see, this is a future value question, first of all, and he's just depositing for a specific amount of time. All the information is given here, and we just want to find out, will he have enough money, okay, to buy a computer that costs this? So we're not really taking this as the as the future value, because we don't know what his future value is yet. We have to use the information that we have about him, meaning when he starts depositing, when he ends depositing, the amount he keeps depositing, and the interest at which his money is gaining interest. And we're going to use that to find out how much he will have. Then we will compare it with the 13,000 to see if he actually has enough money for that new computer. So first of all, let's focus on the deposits. They told us that on the 31st of January, right, that was 2022, that he deposited 1,000. Then he continues, okay, that paid this. Then he continued depositing 1,000 on the last day of every month. He deposited first on the last day of January and then every other month all the way till the 31st of December, which is also the last day of December. So from the 31st of January all the way to the 31st of December, also 2022, these are all the deposits that he's making. He's making deposits of 1,000 Rand. Okay, so let's count how much deposits this is going to be. And remember, the amount of deposit in your future value formula, that is your N value. So the amount of deposits from the 31st of January to the 31st of December will be a total of 12 deposits, because he's deposited every month. Okay, from January to December, there are 12 months. So N is equal to 12. We know that. So if we write down our future value formula, just so that we know what to look for, our future value formula is this. We have X, open bracket, open a small bracket, 1 plus I, raised to the power of N minus 1 over I. Okay, so let's look at what they asked us to find. We just have to find out, will he have this amount? So let's find out how much his future value is going to be. We're trying to look for the future value, first of all. What is the X amount? Okay, the X is basically how much he keeps depositing consistently. That is the 1,000 Rand. He keeps on depositing 1,000. So we know that. And then the interest is 7.5%, but we need to put that as a decimal. So 0.075. And did they tell us the compounding? They said compounded monthly. Okay, so 0.05 divided by 12. It needs to be shared into 12 months. Then we have N. Now N tells you the amount of deposits, okay? And we know how many deposits that is. That is 12 deposits. Okay, so other than this, there's nothing else. There's no other special thing happening, because we just have to find out how much he's going to have on the 1st of January, which is just a day away from that last deposit. So no interest will be earned, because interest will only be earned every month, compounded monthly. Okay, so we're just going to put this into the formula. This one is quite simple. So this is equal to future value will be equal to 1,000. So using that, open bracket 1 plus 0.075 over 12 raised to the power of 12 minus 1, and then over 0.075 over 12. And you could just put this onto the calculator and let's see what we get. And this is how much we have. So we're going to round off to 2 decimal places. He ends up with 12,421 Rand, and round off to 2 decimal places, 22 cents. So all we have to do here is, this is how much Tino saved up, right? The question is, will he have sufficient funds in the account on the 1st of January? Remember, the 1st of January of 2023 is just 1 day away. He doesn't earn any interest. So we already found that. We just have to find out, will he have enough money? This is how much he has in his account. So will he have enough money? He was supposed to save up 13,000, but he only saved up 12,421. Okay, so no, he will not have enough money. So I'm just concluding, he will not be able to buy the computer because he will be a specific amount short, and we can just find out how much short he is. Okay, so he will not have sufficient funds to buy the computer because he will be, now I'm just calculating how much he needs extra. So he needed 13,000, but he only has this. So if we say 13,000 minus the 12,000, we will find out how much short he is. So just go ahead and say 13,000 minus the 12,421.22 cents. Okay, so because he will be And as we can see, 578.78 cents short. So he will not have that amount. Okay, so that is all for this question. Okay, so we are on question 6.3, and 6.3 says, Thabo plans to buy a car that costs 250,000 Rand. He will pay a deposit of 15% and take out a loan for the balance. So he's paying a deposit of 15%. The remaining is going to be the loan. Okay. The interest on the loan is 13% per annum, compounded monthly. 6.3.1, we have to calculate the value of the loan. Okay, remember, he is buying this car. It costs this amount. He's going to pay 15%, and then the remaining is going to be the loan. So if you can find out how much he's going to pay off and remove that from the loan, you find out how much he's going to take out on a loan. So the car costs 250,000 Rand. He is only going to pay a deposit of 15%. This is the deposit. Okay, so 15% is the deposit. The remaining is going to be the loan. So think about it. If 15% was your deposit, how much is going to be the loan? The loan is going to be whatever 100% minus the 15% is. That would be the remaining part. That's the loan. And that's going to be 85%. So we just have to find that. So we have to just find out what 85% of this money is going to be, and that will be our loan. So you could just say the loan is going to be equal to 250,000 Rand multiplied by 85%, which is 85 over 100. And so this is going to be equal to, let's just see what we get. And that is 212,500 Rand. So that is how much the loan is worth. Okay, that was for 1 mark. Yeah. So moving on to the next question, 6.3.2. So the next question says, the first repayment will be made 6 months after. Okay, let's take note here. First repayment is going to be made 6 months after the loan has been granted. The loan will be repaid over 6 years, okay, after it has been granted. So full period of 6 years. We have to calculate the monthly installment. Okay, now this is present value because now we are trying to find out the repayment on a loan. When you speak about loans or anything that was borrowed and you have to pay it back, that is going to be present value. Future value would be for anything that is being saved up. You see, money is being saved up or anything's being saved up and it is consistent. It's a consistent amount that you keep saving for a consistent time period, like every end of the month or the beginning of the month, then that will be future value. Okay, so in this case, this is present value. So I'm going to actually write down the present value formula so that we can just focus on the things we are specifically looking for. So the present value formula is X, open bracket 1 minus 1 plus I raised to the power of negative n. Don't forget that n must be negative over I. Okay, so this is our present value formula, and let's focus on everything that they're asking for. First of all, they told us to calculate the monthly installments. So the installments that you're going to pay, that is X. So we are looking for X. That means we have the present value. So we have to see what the present value is going to be. Now, the loan amount is this. But now the reason I can't jump to the conclusion that, oh, okay, this is the present value is because they said something. They said the first repayment will be made 6 months after the loan has been granted. See, this is what this is going to do to this account. He's making this payment, the first payment, 6 months after. On a timeline, this is going to look like this. So we're going to have T0, where the loan is granted. So granted. And then he starts making his payment only 6 months after. So I'm treating these as their months. At T6, he starts making his payments. This is how you have to think about this. The loan was granted. The loan of how much? This amount. There's 212,500. That was the amount granted. But he only starts paying here. Okay, you have to remember this rule about future value and present value. In present value, you always start paying back your installments 1 month after. This is, of course, if you have been given an interest that has been compounded monthly, then you're going to have to start 1 month after. If it was compounded yearly, you're going to start 1 year after. If it was compounded quarterly, you will start 1 quarter after. So you always start 1 period after. So this is what I'm saying here. Here, his loan was granted at T0. He was supposed to start paying 1 month after, which would be at T1. The problem is he didn't start paying at T1. He started paying 6 months after the loan was granted at T6. So he has missed some payments, but you're going to have to count how many payments was missed. So to calculate the amount of payments that he missed the first payment, the second, the fourth, the fifth, and then he made a payment here. See, because he starts paying at the 6th month. So first payment was made 6 months after. He starts paying here. Of course, that is 6 months after that loan was granted. Okay, so he was supposed to pay here. That means that he missed 5 months. Okay, 5 months of worth of payments was not paid. So we have to remember that the missed payments was 5 months. So because he missed 5 months, he's not going to owe this anymore. He missed 5 whole months. This money is going to grow for 5 months, and that's what he's going to owe. So we need to take this money, and at the interest rate that this account is being charged for, which is the interest rate they already mentioned here, 15%, right? And of course, it is per annum compounded monthly. So we're going to have to grow this money for 5 months using the compound growth formula. So that would be A is equal to P bracket 1 plus I raised to the power of N. Okay, so A is equal to, and we're going to take this amount and grow it, okay, for 5 months. So 1 plus, what was the interest? Okay, so 15% is not the interest. That is just the amount that he's paying from the deposit, basically. Okay, so how much he was depositing? So 13%, that is the interest on the loan. Okay, so just keep that in mind. 13% is the interest on the loan. So I'm saying 0.13 over 12, because it's compounded monthly, raised to the power of 5. I don't have to times this by 12 because this is already in months. I'm growing it for 5 months. Okay, so you can put this onto the calculator and see what you get. And we get 224,262.53 cents. That's how much he ends up owing. Okay, now to be safe, I actually wouldn't round off. The reason why is because this is not the final answer. The final answer is to find X, okay, to find the monthly installment. So I would actually just leave this to be safe to to at least 4 decimals. That should be good enough. So I'll say 544, and I'll just leave it like that. So 54, let's just stop there, just to be safe. Okay, so now we know how much he owes. That's the present value. That's your loan amount. Present value will always stand for the amount the person owes. This is how much he owes. So that is that amount, 224,262.5254. I'm just leaving it at that. So we have X, we have P. What is the interest? We already know that the interest is 0.13 over 12. The interest for that whole loan account is that. And then N. Now we have to figure out what N is. Now remember, in your present value formula, they already tell you N is always going to be the number of payments you must still make. Okay, number of outstanding payments. Okay, so let's think this carefully. This loan is going to be for 6 years. They said 6 years already, okay? They did tell us that it has to be paid within over 6 years. So how many months is 6 years? Because these are already in months. See, 5 months was missed. This is the 6th month and so on. So to find out how many months 6 years is, we just say 6 times 12. And 6 times 12 is equal to 72. So 72 months. That's what we have. So we ending at T72. Okay. We are counting how many payments you must still make. He starts paying on the 6th month. So this is one payment over here. Then the next payment happens on the 7th month and the 8th month and so on. So how many payments is going to be made? Well, you're going to have to think about this carefully. Let me give you a small scenario. Let's say we started paying at T3 and we ended our payments at, let's just say, T7. If you said, oh, okay, to find out the amount of payments I must make, I must just say 7 minus 3 and that's my answer. That would be wrong because T3 is a payment itself. This is a payment. T4 is a payment. T5 is a payment. T6 and T7, they're both payments. Now, if you look at that carefully, you see you have 1, 2, 3, 4, 5 payments. It's one more than the amount here because you have to include T3 itself. So just be careful with that. So in order to find the amount of payments, I'm just going to say 72 minus 6, right? Because that's where he starts paying. And 72 minus 6 is, so 72 minus 6 is equal to 66, right? But now I have to remember that I also have to include that 6th payment itself. So plus 1, just like I just showed now with the T3 to T7. So that is going to be 67 payments. Okay, that is the value of n. N is actually equal to 67. So now that we have everything, we can use the present value formula and solve for x. Okay, so putting everything down. Present value is equal to, and then I'm just going to put the formula down again. So the present value, we know what that is. That is this amount, 224,262.5254 is equal to, and then x, we don't know what that is. We're looking for the value of x. And then we open a bracket, 1 minus 1 plus the interest, 0.13 over 12. Raised to the power of negative 67. And then over that interest. Okay, so we're just trying to solve for x. Okay, so to solve for x, you would notice that, you see all of these, they're all numbers and they're being multiplied to x. So in order to get rid of them, you could just divide by everything that is here. So if I divide by everything that is here, what you do on this side, you have to do on the other side because this is an equation. So really, to solve for x, we can just say this number on top divided by this whole thing here. Okay, because that is that. So there. Now, to be safe, what you can do is you can change the way this was written. You don't have to write it like this. It's not necessary. You can do this if you are sure that you can put it on the calculator safely. But you could have also done this. Take this number on top and then just say divided by all of this. So like this, okay? You could have also done that. I'm just going to do this method though. So I'm going to put this onto the calculator and then let's see what we get. Okay, so this is what we get. We get x is equal to 4,724 Rand and 96 cents. And that is the value of x. Okay, so that's how we actually find this. So just be careful to read the question carefully and just take note of everything that they do speak about. Okay, so that is the end of question 6 and I will see you in question 7.